Hello and welcome to Utkarsh Minds Python for Data Science. Today we will see a paired test for ordinal data. So since it is in Python, I will open my Colab notebook. I will name the notebook as paired ordinal because it is on ordinal data, and I will import the usual libraries NumPy and pandas. Then this test will be about data collection, so we will have before and after. We are working with ordinal data, so let us assume that there are some patients and we are taking the opinion of the patients, let us say 20 patients. Before they ate some medicine, what was their opinion? So numpy dot random, I am randomly generating some opinions of patients between 1 to 5 and size equal to number of patients. So randomly generated the number of opinion and then converted all this into a pandas data frame, just like we had done in the previous classes. We will have before and we will have after, and we can print our data frame. So let us see what is my result. We are having before and after the opinion of patients. So before taking a medicine and after taking the medicine, what is their opinion? Has the medicine worked correctly or not? First thing that we can do is get a cross tab of this so that we can see how is the data. So cross tab of before and cross tab of after. Then with the cross tab we can apply our hypothesis test. This test is known as the Wilcoxon signed rank test. So from scipy dot stats import Wilcoxon. Then I will call the function Wilcoxon first on data before and data after, and apply the correction. I will not apply any correction on the data. So with that we have got statistics as this and p-value as this. The p-value is greater than 0.05, that means the hypothesis cannot be rejected, the results are not significant, and the treatment does not cause any difference in the opinion of patients. Assuming that the hypothesis was rejected and there is an opinion difference, we start calculating the effect size. So we have the p-value, we need to convert it into a z value. So norm dot ppf, we will do 1 minus p-value by p. Then we have to apply one calculation further on the z value, that is we calculate the statistic taken from here divided by the square root of number of sample pairs. So the number of sample pairs we will get by data, from the data itself, the number of rows in the data, and that will be my final correlation coefficient. known as the Rosenthal correlation coefficient. So this is the Rosenthal correlation coefficient or the effect size for my data. Once the correlation coefficient is calculated, we need to interpret it in simple language. One correction here, that it is not the statistic, it is the Z value, and we have got the Rosenthal coefficient as 0.29. So further, from the Z value and the table, so we will create an if else statement. So R underscore rows, if it is less than 0.2, then we will print it the correlation or the effect size is very low. Otherwise, if it is less than 0.4, we will print that it is low, and then there are other options. After low, 0.6 will give us moderate, 0.8 will give us strong, and then greater than 0.8 is very strong. So that is the interpretation of this correlation coefficient, which we are getting as very low. So we can say that the effect size is very low, and we did not find any effect of the event on the patients as we applied the Wilcoxon test. That was it. So keep practicing and see this test even in our you can apply this test and on other data, on your own data, and draw the conclusions. Thank you for watching, and keep watching the next video. Bye.